This is awkward now. Alright, so we're going to start out with a magnesium reaction with some HCl to produce magnesium chloride and some hydrogen gas. Now if you turn to Carlton over here, he will explain what is happening.
Alright, so we got magnesium solid and hydrogen mixed in with the hydrochloric acid, and this is the redox reaction. The solid is going to a 2+, which means the magnesium is oxidizing, and the hydrogen is going from positive to neutral, which means that's reducing.
Alright, join me, Carlton. Alright. Ready to light the stick? Alright, so now I'm going to add the magnesium. Ready? You on fire? Go on fire.
And that popping was from the hydrogen gas exploding.
There's water there. There's water there. There's water there. Thanks. And now we are adding the magnesium into the hydrochloric acid.
And the pop is from the hydrogen gas.
Okay, so we're going to explain two different types of cells. First of all, we've got a voltaic cell, like we're going to explain in a minute, which is right here. And then we've also got electrolytic cells, which are like use electricity or heat to get the reaction going. And we've got different terms that apply to different reactions to do with electrochemistry. So we've got delta H, which is entropy, first the change in heat energy. Then we've got delta S, which is the change in entropy, or the amount of disorder or randomness in the system. And then we've got delta G, which is the change in free energy, and that basically can be used to predict a reaction. So if we look at the reaction here, we've got an iron strip and a magnesium strip, and we've got iron nitrate and magnesium nitrate, and we're going to insert the strips in here and let it start to react. Now we've got a salt bridge in the middle here, where it basically lets the ions flow through it. And the ions are basically going from the magnesium to the iron, because the iron is the thing that's reducing and it's gaining electrons, and then the magnesium is oxidizing, so it's losing those electrons. And this is it's potassium nitrate in here with agar gel, and the K positive ions go towards the Fe anode, and then the NO3 negative ions go towards the magnesium anode. And basically the electrons are just flowing through it. Okay, so the electrons are just flowing through it, and the reason that happens is because the anode is the positive go to the positive one of these strips, and the negative ions go to the negative one of these strips. So that's the overall reaction, and yeah. So after that terrible explanation of what is actually going on here, you can see with this light bulb right here that's lighting up, it means that there's an electric current going through these cables and into here. Now we're going to explain how this happens. See, we've got Leo here, it's a lion. So you can use the mnemonic. Leo the lion says girl and women. Yeah, I know. Can you write the board?
Huh?
No. Right on the board.
Right,
okay, so Leo the lion says girl. We've got it right on the board here. So losing electrons is oxidation, and then gaining electrons is reduction. So if you remember this, you can get a 5 on the AP test. But if you don't remember this, then just don't write your name in the test, because you'll fail. And then we've got a simple reaction here. If I show you on the board up here first, this is called the activity series, and it's got all the reduction potentials for all the different elements on it. And if they're at the bottom, they're more likely to be oxidized, and at the top, they're more likely to be reduced. So say we took something like this, we took fluorine, and then we took lithium. The fluorine is more positive, so it's going to force this negative to become a positive. Like in this equation, we have the iron and the magnesium. There's a double negative here, so you've got the reduction potential for the iron, which is 0.771, negative the reduction potential for the magnesium, so then you would get 3.401 overall, and that is the voltage for the cell. Okay, and then that was basically just a simple equation that you need to know, so just review it over and over again, and you will basically get it. So yeah. Okay, so as you can see right here, the voltage it's not going to be exact because it's real life obviously, but you can see that the voltage is round about 3 point something, because it's between the 0 and the 5, so you can estimate that that's, because you've got the theoretical value, that's generally what the value is going to be about.
So as you can see here, copper was reacted with silver nitrate to produce solid silver and some copper nitrate. And the copper was the oxidizing agent, and the silver was the reduction agent.
Okay, I have the 1 molar.
So in this reaction, we're going to react solid copper with some AgNO3 to produce solid silver, which is pretty expensive, and some copper nitrate. And the copper is going to be the oxidizing agent, and the silver is going to be the reduction agent. And as you can see, some silver was produced along the side of the copper.
That they may take our lives, but they'll never take our freedom!